Hello students, hope you're fine and safe. We will start today with chapter 2, the mechanical action and forces. For the objectives, we are going to identify the mechanical effects of a force, and then the second part, we want to identify the characteristics of a force. What's a force? A force is a mechanical action exerted by one body on another body. So we have one body which is producing the force, and the other body which is receiving the force. So what do we mean by mechanical action? Mechanical action is any type of movement. So let's see this example. To move a shopping cart, the boy has to exert a force on it. So the boy is the one who is producing the force because he is moving the cart. The cart is the object which is receiving the force, and as a result, it will move through the supermarket. Okay, so let's now learn about the mechanical effects of a force. So mainly we have three effects of a force. The first effect states that a force can set a body in motion. What do we mean by a force can set a body in motion? So let's see this example. A boy who is pulling a box. So first, before the boy pulled this box, the box initially was at rest. So when the boy pulled this box, it changed its position. So now it's set in motion because it's changing its position with respect to time. And this is what we learned in the first chapter, the motion. So this is about the first effect. The first effect states that a force can set a body in motion. Now, let's learn about the second effect of a force. So, a force can modify the motion of a moving body by changing its direction, or changing its speed, or preventing its motion, or they can be combined together. Okay, so changing its direction. Let's look at this boy. So, the boy is kicking the ball. So, the leg of the boy is producing the force, the ball is receiving the force, and he is changing the direction of the ball by kicking it and also changing its speed. Okay, let's look at this goalkeeper. So the goalkeeper is holding the ball. So he is preventing its motion by holding it. Okay, so the second effect states that the force can modify the motion of a moving body by changing its direction, changing its speed, or preventing its motion. The third effect of a force states that a force can deform a body. So what do we mean by deform a body? Deform a body means change its shape. So this man is squeezing these marbles. So he is changing their shape. Also, we can get the lemon juice from a lemon by squeezing it. We are changing its shape, we are obtaining the juice. So this is what's meant by a force can deform a body. So deforming a body means changing its shape. Now let's move to the characteristics of a force. We have mainly four characteristics of a force. Let's start first with the point of application. Point of application is the point where the force is applied. So let's see the boy who is pulling a trolley. Okay, the point of application is between his hand and the place where he holds the trolley. Okay, let's see the football player. The point of application is the point where uh, the foot of a player hits the football, as seen in the figure. The second characteristic of a force is the line of action. So it could be vertical, horizontal, or oblique. Let's see this boy. He is pulling the rope horizontally. This boy is pulling the rope obliquely, and this one is pulling it vertically. So now, what about the third characteristics of a force? We have the direction. The direction can be upwards, downwards, to the right, to the left, or it can be upward to the right. It can be upward to the right. This is it. It can be upward to the left. This is upward to the left. It can be downward to the right, and it can be downward to the left. Fourth and the last characteristic of a force is the magnitude. So, the magnitude of a force is measured by a spring balance or as called dynamometer. The SI unit of the magnitude is Newton N. The adjacent figures show different types of spring balances, and a spring balance can have a scale. So the last characteristic of a force is the magnitude. So to find the magnitude of the force, we use the following formula. The magnitude equals to the reading times the scale. Let's look at the reading. The reading is where the needle of the spring balance indicates. So in this case, it's 60. Okay, the scale on the spring balance is given 0.1 Newton. So we say simply 60 times 0.1 Newton equals to 6 Newton. So as we said, the magnitude equals to the scale times the reading. We can use this triangle in order to obtain the other values. So we have the magnitude here, the scale, and the reading. So the magnitude equals to the scale times the reading. The scale equals to magnitude over the reading, and the reading equals to the magnitude over the scale. Okay, students, so we are done with the first part of chapter 2, the mechanical action and forces. We have identified the mechanical effects and the characteristics of a force. Please, if you have any questions, don't hesitate to contact me. Stay safe. Bye.